أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. In continuation to our previous lecture that uh, we had studied, the position of the front view of a point with respect to the xy line is dependent on its position with respect to the HP. So we have seen that the position of the front view is dependent on its position with the horizontal plane. For example, if a point is above the horizontal plane, so its front view will also be above the xy reference line. If the point is below the horizontal plane, so its front view will also be below the xy reference line. And if the point is within the horizontal plane, so its front view will also be within the xy reference line. The distance of the front view of the point from the xy line is the same as the distance of the point from the HP. It means that if, for example, the point is 10 millimeter above the horizontal plane, so its front view will also be 10 millimeter above the XY reference line. If the point is 10 millimeter below the horizontal plane, so its front view will also be 10 millimeter below the XY reference line. And if the point is within the horizontal plane, so the front view will also be within the XY reference line. So the front view is dependent on the horizontal plane, its relative position with the horizontal plane. It has nothing to do with the vertical plane. Now let's see the position of the top view as compared to the front view. The top view would depend on its relative position with the vertical plane. For example, point in front of the vertical plane and above the horizontal plane. So you already know that if a point is above the horizontal plane and in front of the vertical plane, so the point must be lying in the first quadrant. And if the point is lying in the first quadrant, so its projection will be according to the first angle projection, as we have already discussed that. Now, as we are examining the top view, so for example, this point A is lying in the first quadrant. If we are looking into it from this side, so its front view will be drawn on the vertical plane at this position above the XY reference line. But we are interested in the positioning of the top view. So for the top view, you can see that if we look at the point from above, sorry, this line is not very straight, from above like this. So its image or projection will be drawn on the horizontal plane at this position, and you will annotate or you will show it or denote it with a small case letter without a prime on it. So it shows the top. Now I have told you that once you got the top view on the horizontal plane, because top view will always be formed at the horizontal plane and front view will always be formed at the vertical plane. So here is the top view. Now, after getting the top view on the horizontal plane, I have told you that you will have to rotate the horizontal plane about 90-degree clockwise so that it merges with the vertical plane, and in such it will be exactly aligned with the front view. Now, I have told you that the alignment, for example, what is the advantage of alignment? For example, if I am drawing the front view of, let's say, of a duster, let's say front view. Now, let's say that it is the front view and it has a top view because you can judge that the duster is made of six planes. Six planes. As let me show you. I am able to show. Let me show. So, for example, I have this mobile, and you can see that this mobile is made of six plane. This one plane, and behind this one two, this plane, and this plane four, this plane, and this plane. So there are six planes basically. So for the duster, you will have the same. You will have the six plane. So let's say I am holding the duster like this, and this is my front view. This is my front view, and this will be my top view. So I will show this plane or this surface in the front view as I've drawn it, and this plane as the top view, and this plane as the side view. So you can see that the top view is of similar length. You can see that the length is common for this plane as well as for this plane. So I can draw projector. You will do it with the help of set square, and only I will have to measure its width because this length dimension which has already been measured in the front view doesn't need to be measured again, and you can do it by aligning it with the front view. So this is how to make your sheet efficient because this dimension, this length is redundant, or you don't need to be measure it again. As well as, for example, if you are drawing the side view of this as well, so you can align it with the front view, and its side view will be this. So one dimension, this is that is the height which has already been measured in the front view doesn't need to be measured again. You will have to measure only the width, this, or the thickness, you can say. So this eliminates the redundancy of the measurement. Otherwise, it would not affect the shape. For example, the front view would remain the same whether you aligned it with the top view or not. The side view would remain the same either you draw it here or in alignment to the front view. If you draw it here, so you will have to measure the height as well as this thickness. You will have to measure both the dimensions. By aligning it, you eliminate the measuring of this height, you only measure this thickness. So this is why we aligned or rotate the horizontal plane in order to align it with the front view, in order to align the front view with the top view, and also the front view with the side view due to this alignment. So in order to do that, you will have to rotate the horizontal plane about 90 degrees. So this top view will goes to this position. Now you can see that when you rotate the horizontal plane and it merges with the vertical plane, so this top view which was drawn on the horizontal plane will also be shifted to this position. And you can see that this position is below the XY reference line. So for a point in the first quadrant, the top view will always be below the XY reference line. And the front view, as you can see, will always be above the XY reference line because it is the case of the first angle projection as well. So the front view is coming below the XY reference line when the point is in front of the vertical. If the point or any entity is in front of the vertical plane, so its top view will come below the XY reference line. Now, if the point is below the horizontal plane but still in front of the vertical plane, so again, for drawing the top view of this point, looking at it from the bottom or looking at it from the above, the top view will be formed at the horizontal plane at this position. The horizontal plane at this position. Now, after getting the top view at the horizontal plane, look, you can look at it that the top view is this much in front of the XY reference line. Now, when you rotate the horizontal plane, so the similar distance, this one will be rotated. For example, if the point is 10 millimeters in front of the vertical plane, its top view will also be formed 10 millimeter in front of the vertical plane, and when you rotate it, so the same distance will be rotated or will be shifted. So you will have the top view below the XY reference line again, and how much below? That much which the point is in front of the vertical plane. For example, if the point is 10 millimeter in front of the vertical plane, so its top view will be formed 10 millimeter below the XY reference line. So again, you can see that as far as the point is in front of the vertical plane, so its top view is coming below the XY reference line. Again, the top view will be below the XY reference line. Now another case, the point is now in the horizontal plane or within the horizontal plane, but still in front of the vertical. So when you look at it from the above or from the below, from the bottom, its top view will always be created on the horizontal plane, and in this case, at this position. So when you get the top view, you will have to rotate the horizontal plane about 90 degree. So this top view will be shifted to this position below the XY reference line. Now, how much will it be below the XY reference line? This much. The distance which the point was in front of the vertical plane, so its top view will be that much below the XY reference line. So you have seen that as far as the point is in front of the vertical plane, no matter if it is above the horizontal plane, below the horizontal plane, or within the horizontal plane, its top view is coming below the XY reference line. If a point is in front of the vertical plane, its top view is always below the XY reference line. Now, again, The point is now above the horizontal plane and behind the vertical plane. So you can see that for drawing its top view, looking at it from the above or from the below, its top view will be drawn at this position on the horizontal plane. And after getting the top view on the horizontal plane, you have to rotate it about 90 degree. So this half of the horizontal plane will merge with the vertical plane, but above the XY reference line. So this top view A will be shifted to this position above the XY reference line. Now, how much will it be above the XY reference line? That much which the point was behind the vertical plane. So if the point is, for example, 10 millimeter behind the vertical plane, so its top view will be coming 10 millimeter above the XY reference line. So it is the top view coming above the XY reference. So it is A. Now again, the point is still behind the vertical plane, but this time it is below the horizontal plane, that is in the third quadrant. So again, looking at it from the bottom or from the top, its top view will be formed at the horizontal plane at this position. After getting the top view, you have to rotate it about 90 degree, and again you can see that the top view will come above the XY reference line. So again its top view will be above the XY reference line. How much? That much which the point is behind the vertical plane. So again, and the third case, the point is still behind the vertical plane, but this time it is within the horizontal plane. So for its top view, looking at it from the top or from the bottom, its top view will be created at this position on the horizontal plane, and by rotating the horizontal plane about 90 degree, so this will be shifted to this position, which is again above the XY reference line. So you have seen that as far as the point is behind the vertical plane, no matter if it is above the horizontal plane, within the horizontal plane, or below the horizontal plane, its top view will be coming or will be found above the XY reference line. So if a point is behind the vertical plane, its top view is always above XY reference line. Now, point within the vertical plane and above the horizontal. So we have seen the cases of the top view with respect to the vertical plane, in front of the vertical plane and behind the vertical plane. Now is the case for a point to be within the vertical plane. So you can see that now the point A is within the vertical plane and above the horizontal plane. So for its top view, looking at it from above or from below, its top view will be formed on the horizontal plane, but this time at this position, which is a common XY reference line. Now, rotation will not change the position of this top view because there is no distance to be rotated as it is at the origin or common line. So, rotation will not change its position. So, the top view is coming within the XY reference line when the point is within the vertical plane. So, its top view will be within the XY reference line if the point is within the vertical plane. Now again, the point is still within the vertical plane, but this time it is below the horizontal. So looking at this point from the bottom or from the top, its top view will always be created on the horizontal plane at this position, which is an XY reference line. And rotation again will not change the position of the top view, and the top view would remain on the XY reference line after rotation. So again, the top view is within the XY reference line. Now, if the point is within the vertical plane and within the horizontal plane, so you can see that this must be this location within the vertical plane and within the horizontal plane. So for drawing its top, you looking at it from the above or from below its top, you will be created at the horizontal plane at this position, which is a common line XY reference line. So again, the top view is coming within the XY reference line when the point is within the vertical plane. So if a point is within the vertical plane, its top view is always in XY reference line, no matter if the point is above the horizontal plane, below the horizontal plane, or within the horizontal plane. But if the point is within the vertical plane, its top view will always be within the XY reference. So the position of the top view of a point with respect to the XY line is dependent on its position with respect to the vertical plane. It has nothing to do with the horizontal plane. The distance of the top view of the point from the XY line is the same as the distance of the point from the VP. If the point is 10 millimeter in front of the vertical plane, so its top view will be coming 10 millimeter below the XY reference line. If the point is 10 millimeter behind the vertical plane, its top view will be 10 millimeter above the XY reference line. And if the point is within the vertical plane, so its top view will also be within the XY reference line. So the top view, the positioning of the top view is dependent on the positioning of the point with respect to the vertical plane. So position with respect to the horizontal plane, position with respect to the vertical plane, front view with respect to the XY reference line, top view with respect to the XY reference line. Now you can see that the position of the front view is dependent on the position of the point with respect to the horizontal plane. So if the point is above the horizontal plane, so its front view will also be above the horizontal plane. Point above, front view, above, point above, front view, above. If the point is below the horizontal plane, now its front view will also be below the horizontal plane. Below, 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 below. If the point is within the horizontal plane, its front view will also be within the horizontal, within the XY reference line. Within, 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 in. Position with respect to the vertical plane will affect the top view. So, for example, if a point is in front of the vertical plane, its top view will be below the XY reference line. If the point is behind the vertical plane, its top view will be above the XY reference line. If the point is within the vertical plane, its top view will also be within the XY reference line. In front, below, behind, above, within, within, in front, below, behind, above, within, within. So, how to draw or uh, how to draw views of a point on your drawing sheet? As I have told you, you don't have to draw these plans on your drawing sheet. These plans have been drawn only for your understanding that you understand the relative position of the given point with respect to the two principal planes of projections. For example, and you will understand the relative position of the point with its description, with its given description. For example, a point A is 35 millimeter above the horizontal plane and 50 millimeter in front of the vertical. So this must be the first quadrant because the second quadrant must have this 50 millimeter behind the vertical plane. For the third quadrant, if the point is in the third quadrant, so it must be below the horizontal plane in the fourth as well. So if a point is above the horizontal plane and in front of the vertical plane, so this must be the first quadrant. And this point is 35 millimeter above the horizontal plane. You can see this one, 35 millimeter above the horizontal plane and 30 millimeter in front of the vertical plane. So for drawing its two views, for the top view looking at it from above or from the bottom, its top view will be created at the horizontal plane at this position, which is 50 millimeter in front of the vertical plane. So you have to rotate this horizontal plane about 90 degrees. So the same 50 distance will be rotated, or you can say that the top view will come 50 millimeter below the XY reference. And as the point is 35 millimeter above the horizontal plane, so its front view, looking at it from this side or from other side, the projection would be drawn on the vertical plane and it will be exactly 35 millimeter above the XY reference. So you don't have to draw these plans. These plans are only for depicting or conceiving the exact location of the point, and then you will have to draw it according to the projection method. So for example, if the point is in the first quadrant, so its projection will be according to the first angle projection. In first angle projection, the front view will be above the top. So you can see that the front view is coming 35 millimeter above. So and the top view will be in exact alignment with the front view, but you can see that the top view is forming 50 millimeter in front of the vertical plane, and when you rotate it, so it will exactly be rotated 50 millimeter below the XY reference line and in exact alignment. You draw the top and give it a dimensions. This one is 35 and sorry, this one. So you are done with. So this must be the final projection that you will have to show it on your drawing sheet. Only the XY reference line and the relative position of the front view and the top view, along with the dimension and along with the dimension lines. Also the extension line. So this is how to project a point. That's end of today's lecture. Inshallah, we will continue uh, its further. Uh, we will continue its remaining part in the next lecture. Inshallah. I hope you have understood this. Thank you.